This conference will now be recorded.
Okay, thank you, Chindu. Fine. So now the session is getting recorded. Now let me share my screen. Okay. So what was the concept we have discussed yesterday?
We were looking at the log only. The log complete. The module is completed.
Okay, so the transaction logs has been complete. Okay.
Yes.
Now security is still pending. So today we are going to discuss a new concept that is called clusters. Correct? Okay.
Sir, you are not audible.
Sorry.
You are not audible.
Am I not audible?
No.
No, you're audible to me, sir.
Can you try to increase the speaker volume in your computer, Rahul?
So there is a background voice.
It's not from my side.
Okay, I guess
Okay.
it was
Hope
from
there is.
the side. No problem, sir. Okay, I
Yeah,
am
yeah.
muting my.
Yeah, I
All
have
right.
muted myself.
Sure, no problem. Okay. So today we are going to start with module 11, which is clusters. So let me put it in progress so that we have it back. Okay, fine. So clusters. Hope you guys can see my PPT. So today we are going to start a new concept that is called clusters. So before going to discuss about the clusters, let's see some background overview why clusters came into picture, and when we have already a good concept called point to point setup to establish a communication between two queue managers, why we need to go for cluster setup, what is the reason behind. So the thing is, there are certain challenges in the point to point setup. So to overcome those challenges, IBM came up with a new solution that is called clusters. So all the limitations of point to point setup can be overcome with the help of clusters. So let's see now what are those limitations. So the first limitation is the human efforts are needed more and more for the administration. So in the point to point setup, the human administration efforts are needed more. So for example, if I want to build a point to point setup, so the thing is, let's assume there is a queue manager called A and there is a queue manager called B. So to establish a point to point setup between queue manager A and queue manager B, let's assume A is a sending queue manager, B is a receiving queue manager. So in A queue manager side, we need to have a remote queue, a transmission queue, and a sender channel pointing to queue manager B. And in B side, we need to have a receiving queue, a receiver channel, then a listener, so that the message, the point-to-point communication can be established. And then we need to start the sender channel manually. So this is what the basic point-to-point setup. So to establish this point-to-point setup, we have created how many objects? Remote queue 1, transmission queue 2, sender channel 3, receiving queue 4, listener 5, and receiver channel 6. So total 6 objects we have created. All right. Now let's assume the business has been expanded, and let's assume one more queue manager has been came into picture. So this is B. Now you need to establish a communication from A to C. Here A is the sender and C is the receiver. So in A queue manager, you need to have another remote queue which is having the remote destination of queue manager C, then another transmission queue, then another sender channel pointing to queue manager C. Then in C queue manager, we need to have a receiving queue, a listener, and then a receiving channel. Now the objects got increased in your MQ architecture. Now, for example, if you need to establish a communication from C to B, so here C is a sending queue manager, B is a receiving queue manager. So in C sending queue manager, you need to have a remote queue that contains the remote destination details of B, and then a transmission queue, and then a sender channel pointing to queue manager B, and in queue manager B, a receiving queue, a receiver channel, and a listener is already there. So it means whenever your architecture becoming more and more, your objects are becoming more and more. So it means the complexity of administrating become more challenging. Correct. So this is one of the biggest challenge in the point to point setup. Now, second challenge is there is no high availability. So the thing is, in the point-to-point setup, let's assume A and B are connected to each other via point-to-point setup. So let's assume A is a normal application, like the application connects to queue manager. That's like a normal application. If the application is down, that's fine. It does not impact any business. But the receiving application B is a very, very critical application. If B is not received any messages for 1 hour, let's assume there is a financial loss to the organization. So the application connects to queue manager B, it is having that much impact over the business. So the thing is, let's assume application A is down due to some issue. We don't know the issue, we don't know the reason, but application A, this queue manager is down. So whenever sending queue manager is down, there is no way that the receiving queue manager can receive the messages. So whenever queue manager B is not receiving any messages, it means the receiving application is not able to serve any messages. It means it is going to impact the finance. It is going to impact financially to the organization. But there is no problem in B. The problem is somewhere. It is impacting somewhere. So this is another challenge in the point-to-point setup. It means if something is down, that's it. It's down. There is no other way that receiving application can receive the messages. So this is another challenge in the point-to-point setup. Now there is no workload in the point-to-point setup. So for example, there is a point-to-point setup. Let's assume there is a queue manager A, there is queue manager B connected in a point-to-point setup. So A is having a remote queue, a transmission queue, a sender channel. B is having a receiver channel, a listener, and then a receiving queue. So let's assume A is continuously sending the messages. So per second, it is sending, so per hour, it is sending 1 million of messages. It means this queue will be filled with 1 million of messages in 1 hour. 2 hours, 2 million. 3 hours, 3 million. 4 hours, 4 million. So it means whatever the burden that is going to come from queue manager A, that has to be handled by this queue which is in receiving queue manager B. So the thing is, if whenever the queue is having more and more messages, it is causing the high resources in the server of queue manager B, high CPU utilization, high RAM, high memory, high disk, everything is very high, right? So and everything is handled by this queue manager B server only. But in case if we have another queue manager, let's see, and there is a workload balancing between these two queues, the queue which is in queue manager B and a local queue which is in queue manager C. If there is a workload balancing, like if queue manager A is sending 5 million, like 4 million messages in 4 hours, so out of 4 million messages, 2 million will be shared here and 2 million will be shared here. It means 50% will go here and another 50% will go here. So if the architecture is like this, then you are going to decrease the burden on the queue manager B, right? So this workload cannot be done with the point-to-point setup. So all these are the main challenges in the point-to-point setup. All the above challenges can be achieved through IBM MQ clusters concept. So understand with the challenges. Any questions?
Okay.
All right. So we can skip this. Okay. Now cluster. So let's start with the cluster. Okay. So MQ cluster is a group where the queue managers are connected logically. So what is in the MQ cluster? It's very simple. There are certain queue managers, like it could be 1 queue manager, it could be 3 queue managers, 10 queue managers, or 100 queue managers. All these 100 queue managers, all these queue managers are grouped and connected logically. That is called an MQ cluster. So basically, MQ cluster is a grouping of queue managers. They are connected logically. So they never connect physically, but they connect logically. So each cluster in an organization have a unique name. So any organization, like any MQ project, so it can have more than one cluster depending on the business requirement. So each and every cluster must have a unique name. There is no way that with one cluster name, with one name, you can have more than one cluster. No, that is not possible. If we have 5 cluster, it means names, 5 unique names. So a queue manager which is part of a cluster, that is called a cluster queue manager. So till now we have worked on independent queue managers. So they are not part of any cluster. But from today's session onwards, we are going to build a cluster, and in the cluster, if there is any queue manager, that queue manager is called cluster queue manager because it is a member in the cluster now. Now we need to understand some cluster terminology. So the first thing we need to understand is repository. So repository is a very important word in IBM MQ clusters. So let me ask you this question. So what do you know about a repository? Like according to you, what is meant by a repository? Any guess?
It is a it contains the information repository means.
Exactly. Correct. So what is a repository? A repository contains some information. That's it. So a repository in cluster, it is like a centralized store that stores the information about all the queue managers of the clusters and their objects. So for example, I have a cluster, and in the cluster there will be a queue manager. So the thing is, each and every queue manager is going to act as a repository because each and every queue manager will store some information. So for example, till now we have worked on some independent queue managers. So in that queue managers, we have created some local queues, some channels. So we have created few objects. All those objects information will be stored inside the queue manager only. Correct? It means that that queue manager is a repository queue manager. So by default, every queue manager is a repository queue manager because it is contain some information. So best example, our human brain is a very best example for the repository because we are storing a lot of information on our brains. So like that, every queue manager is a repository. In the same way, every cluster is also having a repository, and each and every queue manager inside the cluster is going to act as a repository because they contain some information. So the information is stored in the form of messages and a queue called system cluster repository.queue. So in clusters concept, this object system cluster repository.queue, it plays a vital role. So whatever the object we create inside the cluster, that will be stored in a queue called system cluster repository queue. It's a system queue. It means this queue is getting created at the time of queue manager creation itself. So repositories are categorized into two types in MQ. Okay. Now we have some basic idea what is meant by repository. Now in MQ we have two kind of repositories. They are partial repository queue manager and full repository queue manager. Before jumping into clusters concept, we need to understand these two terms: partial repository queue manager and full repository queue manager. So let's see what is meant by a partial repository queue manager. So a cluster is a combination of both the partial repository queue managers and full repository queue managers. So if you take any MQ cluster in any project across the world, definitely it must be having both full repository queue managers and partial repository queue manager. Now let's see what is meant by a full repository queue manager and what is meant by a partial repository queue manager. So first, let's talk about partial repository queue manager. A partial repository queue manager contains the information of its own only. So for example, I have a cluster, and let's assume in my cluster there are 5 queue managers. So out of these 5 queue managers, few will be definitely partial repository queue managers and few will be definitely full repository queue managers. The reason is a cluster is a combination of both partial repositories and full repositories. Now let's assume out of these 5 queue managers which are members in the cluster, queue manager 1, queue manager 2 are partial repositories. Sorry, queue manager 1, queue manager 2 are full repositories, and queue manager 3, 4, 5 are the full repositories, partial repositories. So 3, 4, 5 are partial repositories in the cluster, right? It means queue manager 3 contains its own information. It doesn't take care of queue manager 1, 2, or 4 or 5. Because it's a partial, it will take care of its own. That's it. So by default, every queue manager is a partial repository. It means, for example, when we create a queue manager, by default, it will be acting as a partial repository. It means till now we have worked on partial repository queue managers because by default, the queue manager is a partial repository. So for example, if I go to the server, okay, let me log in. Oh, come on. Okay. Now let me take the SSH of the session. Okay, there are a lot of sessions. Let me close all of them. All right, I'm taking the SSH. Login as npm. But access dinner. Okay. Okay. Now see, in this server, in our server, there are 3 queue managers: QM1, QM2, QM3. So all these 3 queue managers are partial repositories only. Now I'm creating another queue manager, say queue manager 4. So this QM4 will be a partial repository only by default, because when we create a queue manager, that will be by default act as a partial repository. It means this QM4 will be take care of its own information, like what are the queues inside QM4, what are the channels inside QM4. It will take care of those queue managers, those objects only. That's it. It doesn't take care of the remaining thing, remaining queue managers or remaining queue managers objects inside the cluster. Okay. Now, full repository queue manager. So a full repository queue manager contains the information of all the queue managers and their objects inside the cluster. So for example, in our 5 queue managers cluster example, QM1, QM2 are full repositories, 3, 4, 5 are partial repositories. It means QM1 being a full repository, it contains its own information, and also it contains the information of remaining queue managers and the other remaining other queue managers objects also. Even queue manager 2 is also a full repository. So it also contains its own information and the information of all the remaining queue managers and their objects. That's what the full repository means in a cluster. Okay, so if a cluster having 4 queue managers, say QM1, QM2, QM3, and QM4, let's assume QM1, QM2 are the full repositories and QM3, QM4 are the partial repositories. It means that QM1 contains its own information, QM2 information, QM3 information, and also QM4 information, because QM1 is a full repository of the cluster. Now, QM2, it is also a full repository. It means it contains its own information, QM1's information, QM3's information, and QM4 information also, because QM2 is what? It is a full repository of the cluster. Now, QM3 contains its own information only, because QM3 is a partial repository. The same case with Queue Manager 4. So Queue Manager 4 also contains its own information, and it doesn't take care of the remaining Queue Manager information, because it is a partial repository.
Sir, you said QM3 and QM4 are partial repository queue managers. So how
Right.
it contains the information about QM1 and QM2?
There is a small logic behind it. So the thing is, any partial repository contains the information of full repositories and its own information. It does not have the information of other partial repositories of the cluster. That's what the actual partial repository is. But if I say the partial repository like that, right now you will get confused. That's why I'm blindly saying right now partial repository contains its own information. Okay, but the actual thing is, Queue Manager 3 being a partial repository, it contains its own information and QM1 information and QM2 information, which are full repositories. But it
Okay.
won't have the information of Queue Manager 4 because it's a partial repository.
Okay.
Same way, QM4 being a partial repository, it contains its own information and also the information of QM1 and also the information of QM2, but it won't have the information of QM3 because QM4 is a partial repository. That's what the line here.
Okay.
Okay. All right. Now, making a queue manager as a full repository. So, how to make a partial repository queue manager to full repository? So, by default, when we create a queue manager, it will be created as a partial repository that we already know. So, for example, in this case, we have just now we created a queue manager QM4, and I am starting the queue manager QM4. It's now running. So, by default, this queue manager is a partial repository. So how do we know this queue manager is a partial or full? How can we justify that? How can we technically verify that? Very simple. Just display the properties of the queue manager using display QMGR command so that all the QM4 queue manager properties will be displayed. Out of these queue manager properties, we already know few properties like CR time, CR date, and then dead queue. We already know about these properties. Now today we are going to discuss a new property that is called repose property. It means repository. So by default, repose is having no value. Nothing is assigned to this repose. It means this QM4 is a partial repository. If something is assigned, then it will be act as a full repository. So now, if I want to convert my QM4 as a full repository, the thing I should do is I need to alter repose property of the queue manager property. So it means that name is going to be your NP cluster name. Like whatever the name you are going to assign for a repose attribute, that name is going to become your cluster name. Now the queue manager will become the full repository of the cluster. So the example look like this. Enter inside the queue manager and alter QMGR repos and give any name here. You can give any name, but here I am choosing a name called training. It means in the back end, a cluster with the name training is created, and inside this cluster, this QM4, this queue manager will become a full repository. This is how we convert a queue manager as a full repository. For example, now I am altering repose property of QM4, alter repose, let's assume training. You can give any name here. So this training is going to be my cluster name. Oh, sorry. Alter QMGR repose training. This is the command. Now it's changed. Now display queue manager properties. See, now repose is sent to a name called training. Now in training cluster, our queue manager QM4 is a full repository now. So as simple as that. So this is the way we can convert a partial repository queue manager to full repository queue manager. Done. Now the queue manager will become the full repository in the training cluster. Okay, so that's it. So in MQ, there is no such kind of command called define cluster. There is no such kind of command. You just need to alter the repose property and give your cluster name. That's it. So in training cluster, that queue manager will become full repository. Done. So now got a clarity how to convert a partial queue manager to full repository queue manager. Any questions?
Sir, those who have repository parameter change, in short, they are all members of one cluster? Is that
No,
so?
no. It's not like that. That will become full repository of the cluster, but it doesn't mean that it will become a member. So after changing this one, after changing repose property, still we have to do lot of things.
Okay.
Okay, we have to create some cluster sender channel. We have to create some cluster receiver channel. So those have to be success. Based on that, that queue manager will become a member of the cluster. It doesn't mean that when we just alter this repose property, that will become a member of the cluster. No, it's not like that. Still, this is just a basic step. After this, we have to do few more things.
So for now, it is just a repository concept. Okay.
Yes, for now, it is just a repository. I'm just explaining you how to convert a partial repository queue manager to full repository queue manager. That's it. Still, we have
Okay,
to
sir.
discuss
No
so many things.
problem.
Okay. So make sure every cluster must have two full repositories. So the thing is, IBM always recommends when you are designing a cluster, when you are architecting a cluster, make sure two full repositories are there for your cluster. Because if you create a if you create a cluster with only one full repository, if that full repository is down, that's it. Your cluster will be inaccessible. Because full repository is the only one which will be having all the information of your cluster, like how many minutes are there in your cluster, how many objects are there in a cluster, how many channels are there in a cluster. Everything is managed and controlled by your full repository. If one full repository is down and if your cluster is having only one full repository, then it's always a big problem. So make sure you are having, it's highly recommended that have two full repositories, so that if one full repository queue manager goes down, there is another full repository to manage your cluster. Now making an object as cluster member. So for example, I have a local queue which is an object. I want to make my object as a member of the cluster. So the thing is, so there is a property called cluster for every queue local. You have to just alter that property. So for example, right now we are inside QM4 queue manager, and which is a full repository in the cluster. Now if I create an object, say define queue local QL4, it is created. If I do display QL, this queue local has been created. For this queue local, right now it is not a member of the cluster. Also, although it is physically created inside QM4, but it is not a member of the cluster, because the cluster property of the local queue is empty. It means it's an independent queue. It will never listen to anyone. It's independent. It's a free bird now. But the thing is, if we want to use any object in the cluster, we have to make that object as a cluster member. So we need to alter the cluster property, like alter QL4 cluster, and then give your cluster name training. Now it's been changed. Now display QL4. Now see, for QL4, the cluster property is assigned to a name called training. Now in training cluster, whoever is the full repository, whatever that full repository instruct to this queue local, it is going to follow that order. That's it, because it's a member of the family now. It's a member of cluster now. So this is how we can make an object as a member of the cluster. Now we need to understand what are the channels that are used in the cluster. So in cluster, we use two types of channels: cluster sender channel and then cluster receiver channel. So in the point-to-point setup, we already know about two channels: sender channel and receiver channel. So what is the usage of sender channel in the point-to-point setup?
To establish a communication between sending queue manager and receiving queue manager.
Exactly. So basically, the sender channel sends the message over the network, and the receiver channel receives the message over the network. That is what in the point-to-point it behaves. Now, can you guess what would be the use of cluster sender channel in the clusters?
To establish communication between the queue managers which are there in the cluster.
Exactly. So the thing is, this cluster sender channel and cluster receiver channel, they are going to establish the communication among the queue managers which are connected, which are logically connected in the cluster. So the thing is, simply a cluster sender channel sends the message over the cluster. In the point-to-point setup, normal sender channel sends the message over the point-to-point setup, but cluster sender channel sends the message over the cluster, and cluster receiver channel receives the message over the cluster. As simple as that. So if I want to make my cluster sender channel as a member of the cluster, the thing is, your cluster sender channel, we need to alter the cluster property of the cluster sender channel. So every cluster sender channel and every cluster receiver channel definitely having a property called cluster. So you need to give your cluster name for that cluster sender channel. So normal sender, normal receiver, they won't be having this property. Only cluster sender and cluster receiver will be having this property. So alter channel name, channel type plus SDR. It means I am altering a cluster sender channel. So this channel is a cluster sender channel and I am altering cluster property. And if I want to make a cluster receiver channel as a member of the cluster, you need to alter your cluster receiver channel name. That channel type is going to be cluster receiver and the cluster is going to be name of the cluster, so that that cluster sender and cluster receiver will become a member of the cluster. Done. Okay. Now we have seen some theoretical part about a partial repository, about full repository, and what is the responsibility of full repository in a cluster, and what is the responsibility of a partial repository in the cluster, and how to add an object in the cluster, and how to add a channel in the cluster, like how we can make them as a members of the clusters. That is what we have seen. Now, requirements for a queue manager to be added in the cluster. So if I want to add a queue manager inside the cluster, what are the requirements? So this queue manager could be a partial repository or it could be a full repository. You can add any queue manager inside the cluster. So there is a queue manager. It is a partial repository or it is a full repository. That's a secondary. Although it is a partial repository, these are the requirements we need to take care so that that particular queue manager will be added into the cluster. So the first thing is we need to create a cluster sender channel inside that queue manager. This is step number 1. Step number 2, we need to create a cluster receiver channel inside the queue manager. And finally, we need to create a listener at a port, and then we need to start that listener. So step number 3, we already aware how to create a listener at a port and how to start the listener. We are pretty much aware. Now we need to understand about 2 things: a cluster sender and a cluster receiver. That's it. Now let's see how to create a cluster sender channel. It's very simple. So we already know how to create a normal sender channel. So can anyone tell me what is the syntax for creating a normal sender channel? Or you forgot the syntax? Don't forget the syntax. What is the command to create a sender channel? Point to point setup. Go to point setup and you have a notepad. Open my notepad.
So define channel, then channel 1, channel type sender, connection name, IP address and port number.
Correct. So see, in the point to point setup, there is a sender channel. Here I have written the syntax also. So for defining a normal sender channel, the syntax is going to be define channel, your sender channel name, channel type sender. In the connection name, we have to mention receiver queue manager's IP address and receiver queue manager's port number, and then the transmission queue. So this is the syntax of a normal sender channel. But cluster sender channel, there is a slight difference. It is going to be like this: define channel, channel name. In channel type, we have to mention plus sender. In normal sender channel, it is just like SDR, but in plus sender, it will be plus SDR. It means we are creating a cluster sender channel. And in the connection name, we have to give the receiver queue manager's IP address and port number. So here, what kind of, what connection name we have to give, that I will explain in the next slide. But right now, connection name is going to be there in the cluster sender channel. And then we have to give the receiving queue manager's IP address and port number. So what is this IP address, that we are going to discuss later. Now there is a property called cluster and we have to mention the cluster name. So this channel has to become a member of the cluster, right? It has to become, so that we are going to make the channel as a cluster member with the help of cluster property. That's it. Cluster sender channel definition done. Now let's come to the cluster receiver channel definition. So before that, let's review the normal receiver channel definition. So what is the syntax of normal receiver channel?
Sir, same sir. Like
See, here it is. Define channel, your receiver channel name, and then channel type is RCVR. This is what normal receiver channel. But a cluster receiver, slight difference is there. It look like this. Define channel, channel name, channel type plus RCVR. It means we are going to create a cluster receiver and connection name. So in a normal receiver channel, there is no connection name. But for a cluster receiver channel, definitely there has to be a connection name. And in the connection name, we have to specify a IP address and port number. What IP address and what port number, that we are going to discuss in the next slide. And then we have to mention cluster, and we have to make this channel as a member in this cluster. Done. So the thing is, for a cluster receiver channel, why we have to mention the connection name? This is the important logic here. So there is a very big reason why we need to mention connection name in the cluster receiver. So the thing is, for the sender channel, we are mentioning connection name because this sender channel should go and connect to someone. So that we have to give the connection name. But cluster receiver, it should not go to anywhere, but still we need to provide a connection name for cluster receiver. Why? Because there is a very big reason. That big reason I will tell you in the next slide, not now. Okay. So the thing is, if I take any interview for a person on IBM MQ, in the MQ clusters, I will ask him only one question. And the question I'm going to ask him, why we need to mention connection name in the cluster receiver. If that person gives me a 50% answer, that's it. I will take him in. I will not ask him any further question. I even don't need 100% answer. Just 50% answer is enough for me. So that much importance is there. So this one we are going to see in the next slide. Okay. Now for defining a listener, we already know the syntax. Define listener, listener name, TRP type TCP, and then port number. We have to give a port number here. And here we are going to discuss a new property that is called control property. So the thing is, a listener should be always controlled by the queue manager, even in the point also. Till now, we have not discussed about the control property of a listener. This is the first time we are going to discuss the control property. So by default, control is going to be manual, but here we are going to give the control to queue manager so that the listener will be under the full control of the queue manager. So for example, so in QM4, I am defining a listener. Define listener LSTR4, TRP type TCP, and then port number, let's assume 1425. Done. I have created. Now see, display LS state, display LSTR, LSTR4.
You type wrongly.
Sorry?
TCP you typed wrongly. Like
no, it's correct only, but it's a small letter, right? I have given.
Yeah.
But MQ will take it as a capital letters only. You see, it came as capital T, not small t.
Okay.
Okay. So these are the listener properties. So we already know about TRP type property. We already know about port property. But now see, there is a control property called manual. It means manually we have to take the control of listener. We have to stop. For example, if I see display ls status LSTR4, right now this object is status is not found. Now we need to start the listener LSTR4. It's now started. LSTR4. Now it's running, and you see the control is manual, but I am altering this control to QMGR. Alter listener LSTR4 TRP type TCP control QMGR. It's now changed. Display LSTR4. It's now the control is QMGR. So to take this effect, to take this property effect, we must restart the listener. So I am stopping the listener. Display LSTR4. Now display ls status LSTR4. Now see, display ls status LSTR4. See, now there is no status for the listener. Okay. So the thing is, I will do one thing. I will shut down the queue manager QM4. end MQM QM4. Done. It's now shut down. Now I am starting the queue manager QM4. It's now running. Now, have we started the listener here using start listener command? Have we manually started it? No. But if I check the listener status now, see, now it's automatically running. How? Because the listener is now under the control of queue manager. As soon as queue manager came up, immediately queue manager will start the listener, because this listener is under the control of queue manager. If the control is as a manual, we have to manually start the listener using start listener command. That is the difference between control manual and control QMGR. So for a listener, it is always recommended have it under the control of queue manager, so that you won't have any extra burden. So queue manager will take care of the listener. Okay. So this is what control QMGR. Okay. So now clear. So for every queue manager to be added in the cluster, it should have three things: a cluster sender channel, a cluster receiver channel, and then a listener in the, a listener in the running mode. That's it. Nothing else. Okay. Now setting up a cluster with a 4 queue manager. So for this entire training, what we are going to do is we are going to build a cluster with a 4 queue managers. So when we build this 4 queue manager cluster setup, building a 100 queue manager cluster is also very easy for you, because the steps are similar, very similar. So we need to have minimum one full repository of the queue manager to set up a cluster. So a cluster is always a combination of full and partial repositories. So minimum one full repository must be there. Without a full repository, you can't build a cluster. But it is always recommended to have two full repositories, because if one full repository goes down, another full repository can take care of your cluster. So for this training, what we are going to do is I am going to take 4 queue managers: QM1, QM2, QM3, and QM4. And QM1, QM2, I am going to treat them as a full repositories, and QM3, QM4, I am going to make them as a full repositories in this cluster. So the first step is we need to set up the first step to set up a cluster is we need to establish a GLWay communication between two full repositories. It means, first of all, we need to establish communication among these two, QM1 and QM2, because I want to add these two as a full repositories. Okay. So yeah, so how to build them, what are the technical things we need to take care, we'll see from tomorrow session. But right now in today's session, we just discussed about the theoretical discussion of a cluster. What is a cluster, what is a repository, what are the basic criteria, and what are the technical objects we need. So I strongly recommend you to go through this video, understand the terminology in the cluster, and then from tomorrow onwards we can technically implement the cluster setup. Fine.
Okay, sir.
Okay.
Okay,
So that's
sir.
all for
No
today.
problem.
We'll meet tomorrow at 10 a.m.
Okay. Thank you, sir.
Yeah. Thank you.